Okay, so I've got an example of an angle of elevation. We have to start with the horizontal line. Here is my initial side. Okay, same thing with this one here. My initial side is horizontal. My initial side is horizontal, parallel to the ground. If I look up, my angle, my theta, is an angle of elevation. If I start with a horizontal and I look down, now my theta is an angle of depression. But one more time, you have to start with the horizontal first. Okay? We have a surveyor standing 115 feet from the base of the Washington Monument. The surveyors are those little people that stand on the side of the road with a little tripod and they're looking through it and doing trigonometry to measure things. So I definitely would not take a tape measure and be like, I'm going to measure the Washington Monument. Like, no, right? So we use trigonometry to find out how tall it is. There's an almost exact replica of what it looks like right there. It is on a big ground, a big mound of green. It is. I've been there. And then there's a surveyor that is standing 115, I can't talk today, 115 feet from the base. Okay. The surveyor has, bless you, the surveyor has some equipment that measures to the top of the tower. We have an angle of elevation that is 78.3 degrees. We need to know how tall is the Washington Monument. Okay. It is not 100 feet, but good guess. We're going to set up trigonometry. We're going to set up SOHCAHTOA and solve it that way. So according to my angle, H is which side? H is the, according to the angle, H is the, oh my gosh, you have to answer. Opposite, thank you. And the given side, 115 feet, is the adjacent. So which of my 3 or 6, but I'm only going to use the 3 of them, trigonometric ratios uses opposite and adjacent? Tangent. See, this is like going way back here. Tangent of theta is equal to opposite over adjacent. So what do I know? I know the tangent of 78.3 degrees. That's my angle. I do not know my opposite, but I do know my adjacent. So if we know all the information except for one thing, we can solve for that one thing. Put this over 1. We're going to cross multiply. It is the easiest to type in your calculator. If you put the 115 in front of the tangent, 78.3, because your calculator will naturally open up parentheses and you'd have to close them before you're doing the 115. So it's easiest to type it in that way. Go ahead and type that in. And then I will call on somebody to tell me approximately how tall is the Washington Monument. All right, Belle, did you get it? 555 point. Okay. 314. And if you look up that information, it is 555 feet. So this is an approximation. You would approximate to whatever the question asks you to approximate to. This one didn't. All right, you are in an apartment looking out the window while playing with a laser measure tool. You notice a car driving by 80 feet from your window. You also measure your window to be 40 feet above the ground. What is the angle of depression from you to the car? So there's you playing in the apartment window. You see that car out there. Okay. You're using your laser measure tool. It's a red laser. Down to that car, and you say, "Ooh, it's 80 feet away." And then you point it straight down, and you're like, "Ooh, I'm 40 feet up." We have to find the angle of depression from you to the car. So you are higher than the car. So you are looking down at the car. In order to put that angle of depression in the question, I need to start with the line of sight. I need to have that line of sight first. So once I have the line of sight, then we can look down from that line of sight. And that's where theta is going to go. Okay, so now we're going to go back. I'm going to travel down the geometry road. And I'm going to say theta is not inside of my right triangle. However, it is. It is not currently inside of my right triangle. But do you guys remember anything in geometry about parallel lines? Because your line of sight and the horizontal ground are parallel. And a transversal. What were you going to say, Brandon?
I was going to say alternate interior is the same angle.
So that angle that's theta here is also theta here. So alternate interior angles are the same. Perfect. So now we actually have that angle on the inside of our triangle. So let's find that angle. According to angle theta, what side is 40? Opposite. And 80 is the hypotenuse. So if we have opposite over hypotenuse, you guys know that as what? Sine. So we're going to use sine for this one. Sine of theta is equal to 40 over 80. So to get theta by itself, we have to undo sine. How do I undo sine? Inverse sine. Or arc sine. So get theta equals sine inverse 40 over 80. Go ahead and type that in your calculator unless you can look at it and tell me the answer. Type in the calculator unless you can look at it and tell me the answer. And I will call on someone. The direction I'm standing, it looks like it's straight, but when I go in front of it, I can tell that it's a angle. Daniela, did you get it? What'd you get? 30. Oh, yes, because 40 over 80 is a half. And the question is, where is sine a half? Well, that's 30 degrees. We should know that one. So that would be our angle of depression for this picture. That's not too bad. Nah. We end out the year nicely, okay? Except for that test you got next class. All right, trigonometry and bearings. So bearings are used in navigation. And there's a specific way that we say bearings to understand the navigation. So the only thing you got to remember here is how it's said according to how we draw the angle, okay? So we're always going to either say north or south first. So that's telling you we're going up or down. From there, then we're going to say east or west. All right, so we're going to start with north or south, then we'll say east or west. In between the two is an angle. So you can see 3 examples of bearings here. The first one says south 35 degrees east. South 35 degrees east. So that means I'm going to go south, then I'm going to rotate 35 degrees towards the east. So we first go down, then we rotate to the east, 35 degrees. So in this picture, 35 degrees is this angle. The next one says north. Then it says 80 degrees west. So I turn to the west and go 80 degrees. So that's not like a reference angle. That's just the angle that goes off of the north side. So I guess it's kind of opposite of what we did when we did reference angles. Which is one reason why I took it out of the chapter when we did reference angles. Put it in its own chapter. And then north 45 degrees east. I'm going to go north first. Then I'm going to rotate and go 45 degrees to the east. That theta would be next to the north. So it would be next to the y-axis. Okay? Now we're going to go with a super complicated question. Ready? We have a ship that leaves port at noon and heads due west at 20 knots, which is 20 nautical miles per hour. At 2 p.m., the ship changes course to north 54 degrees west, as shown in this figure. Find the ship's bearing and distance from the port of departure at 3 p.m. So in this picture, it is starting at A. That's the starting port. Okay, that's where we're starting. It's going to go due west. So that means straight west. And we're moving 20 nautical miles per hour. 20 knots. Then the next thing it says at 2 p.m. So here I have 2 times. At noon, we're starting. At 2 p.m., it changes course. So this over here is at noon at A. And then at 2 p.m., we're changing course. That's at B. So you see this line at the bottom, they labeled 40 nautical miles. We're moving 20 nautical miles per hour from noon to 2 o'clock. We've gone 2 hours. So far the boat has traveled 40 nautical miles. Okay? Now it changes course. So at B, this is where most people struggle with bearings. At B, we now have a northeast southwest. What are those things called? What are the things called? Wait, I heard compass, but what else? Yeah, but it's not.
It's like a compass rose or something like that.
Oh, rose? A compass rose? Maybe. I gotta look that up. Okay. Anyway, we got to make one of those right there because when it changes direction, it's now going to be going north 54 degrees west. So here I have to go north, and then I need to go 54 degrees to the west. But that's telling me now where the ship is actually, I was going to say driving. What do you say? Boating? Was it sailing? Okay. So that's telling me now it's going this direction. And it says, find the ship's bearing and distance from the port departure at 3 p.m. So it's telling us that it went 1 more hour, which is 20 more nautical miles. Now we have to find the ship's bearing and distance from the port at 3 p.m. So what we're actually finding, if I go back to the original port and draw one of those compass roses, I think that is what it's called. If I draw one there, we're going to find the bearing to where it finishes at point D. And we're going to find the length that it travels for C. Hi, is it me? Is it me? Oh, yeah. You need to see my So today is not my class anymore. And then she's probably not here at school, but like she's been out for a long time. So it's oh, and thank you. Oh, that sucks. It wasn't me. Okay. All right, where was I? Oh, so our goal is to find this length of C, and we're going to find what's called a bearing. We're going to find that of the end result right here. I bet you could tell me just something about the bearing right now from the picture. Can't tell me the angle. Lydia? It's north and west, right. So our bearing is going to have north and then west in it, just like this bearing right up here says north and then west. It's going to be looking the same way. We're just going to have to find that angle. Okay, so now we have some triangles in here. And I've written all over this, so now I'm trying to find, we're going to find this angle right here. I'm going to find that angle right there. Yes, we're going to start there. Can somebody help me find that angle? How can I find it? I can erase some of the stuff that's on there. How do we find that angle? It's like
36 degrees.
DBC is 36 degrees. Okay. The reason why I found that is because the way they drew the triangle for me to help me out is we have a right triangle out here. If I know that that's 36 degrees in the right triangle and I know one side of my right triangle, now I can find the other two sides. Which side would you like to find first? B? Sounds good. Let's find B. So to find side B, B is opposite of the 36 degrees. And 20 nautical miles would be the hypotenuse. So we're going to say opposite hypotenuse is sine of 36 degrees is equal to B over 20. So I'm going to cross multiply that, and I'm going to get that B equals 20 sine 36. Now, if I type that in my calculator, am I going to get a nice, easy answer? I mean, you can type it in. 20 sine 36. That is ugly. No offense, but it's ugly. All right. So I'm actually just going to leave it as 20 sine 36 for now. I mean, if it's bothering you, you can use your calculator, but it's going to be less work for me to leave it like that. So let me get rid of this word opposite. Oops. And I'm going to put 20 sine 36 for my B value. This 20 sine 36 is the most accurate length. And I don't know if you guys are like aiming towards something and you're off by a couple degrees, but you're not going very far, it's not going to matter. But if you're aiming towards something and you're off by a couple degrees, but you're going for miles, by the time you get way out there, you're going to be like way off the target. So that's what I'm trying to be as accurate as possible as I can. All right, let's find D. So to find D, we're going to set up the same way, only D is going to be the adjacent this side. So we'll use cosine of 36 degrees is equal to D over 20. So D is equal to 20 cosine 36. And again, I can type it in the calculator. I'm going to get an ugly looking 16.18 something number, but I'm just going to keep it as accurate as possible for right now. 20 cosine 36. Okay, so I have these two sides. My ultimate goal is I'm getting C. C is part of a big right triangle. I have the height of that big right triangle. I have to find the hypotenuse. And I do have enough information now to find the length from C to A. How do I find the length from C to A? Sorry, I don't know what I just did there. From C to A, how can I find that length? From C to A, how do I find the length from C to A? John?
You take 40 and add 20%.
Perfect. We're going to take the 40 nautical miles and we're going to add on 20 cosine 36 more. And that's going to be my length for CA. Remember in geometry, when you write length, you don't put the little line over the CA. Just geometry review there. So that's going to be my length of CA. My length of CD, which is also little b, which we've already written, is 20 sine 36. How can I find the length of little c or length of DA? You know? Pythagorean theorem, perfect. So we have two sides of a right triangle. Let's do a squared plus b squared equals c squared. So I'm going to do, and I am going to use my calculator, 40 plus 20 cosine 36 squared plus 20 sine 36 degrees squared. And then I'm going to take the square root of that so I can solve for the little c. So I can type that in my calculator with all the parentheses. I can type it just straight into my calculator. Try to use your calculator and type it straight in without having to do multiple steps. And I would like all of you to try it so you can see if you're typing anything in wrong. and know before you do your assignment that you're typing something in wrong? So when I typed mine in, I got about 57.397. So if we're typing something in wrong and you can't figure it out, let me help you with your calculator. If you've gotten that far, see if you can find the bearing, because we still have to find the bearing. But I'll go over the bearing in a second. Anybody need any help with their calculator? Do anybody need calculator help with typing that one in? Okay. So you say, oh, I have parentheses. So you need those parentheses as well, which you started to do. Did you do that earlier?
Yeah.
Okay. The problem is, I can see right here. So you opened a parenthesis for the 40, but then you didn't close it. You did on that one, or you did, I did an extra. Nope. Oh, the squared. Nope. 40 plus 20. Oh, you have a 2 instead of 20. But you had the 20 there. That must just be one. You just had a 2 instead of 20. Anybody else? Go over. Oh. Hit enter. Okay, no. The square should be on the outside of that. And the same thing with that one. The square should be on the outside of that. Let's see. Okay. Is there anybody else who wants me to help them with their calculator? I'll tell you what, and it depends on your calculator too, but like, you know, the calculator will put a parenthesis here. This is where I thought people might get into trouble, is where to put the squared and where to put that, and to actually put the second parenthesis there. That's kind of where the trouble was happening if you were having any issues. The last thing that we have to do for this question is find the bearing, which we already decided it was northwest by just looking at the picture. You go up and then you go to the west, so it's northwest. We just have to find this angle out here. To find that angle out there, if I can find the angle on the inside, the two of them are complementary. They will add up to be 90. So if I can find the angle on the inside, then I can definitely find the angle on the outside. So what I'm going to do is I'm going to use 2 side lengths, and I'm going to use trigonometry to use the inverse to find that angle, just like we did in the laser pointer question. And I'm going to use the exact side lengths. So I'm going to use side DC and side CA because those are not rounded, where my side C was rounded and uglier. So I'm going to use the opposite and the adjacent. So which trigonometric ratio should I use? Tangent. So we're going to do tangent of the angle I'm trying to solve for equals the opposite, which was 20 sine 36, divided by the adjacent, which is parenthesis 40 plus 20 cosine 36. Now, if I'm doing that on my calculator, it will put extra parentheses in, so keep that in mind. And if I'm doing that on my calculator, I do have to do tangent inverse to get theta by itself. If you have alpha y equals to get the fraction thing, like if it'll bring the little fraction thing up for you, that's going to be the easiest way to type it in. So please type that in and see if you can find the correct bearing. If you don't have the fraction thing, you might need some extra parentheses, but that is one major reason why you should be practicing with me, to see if you know how to do it. So I got 11.819-ish, but I have to do 90 minus that because that is the, no, I don't. Yes, I do. I have to do 90 minus that because I want to find the part on the top. Which is 78.181. So inside is the 11.8. Out here would be 78.181. $78.2. See, it's just that easy. It's not bad. It's just a little involved, but these are like real life application of where we might use trigonometry. Most likely for real life, you aren't going around and finding the sine of 30 degrees. Just randomly. But you could have a job that requires you to find, you could, it's your choice, I guess. There's just one more example and that's it. The last example has to do with air navigation. Air navigation use bearings, but they say them in a different way than we're used to. Their bearings are measured in degrees clockwise from north. So we always start at north for air traffic navigation. And then we go clockwise from north. So this example says a plane leaves Cincinnati Airport at a bearing of 90 degrees and flies for 20 miles. If another plane leaves at a bearing of south 35 degrees east for 50 miles, how far are the two planes from each other? So this right here, where it says a bearing of 90 degrees, it's not telling you any direction. So that would be where we need to know in air navigation, it's always going to start north and go which direction? Clockwise. Clockwise. Yes, east, but clockwise. So we've got a plane that starts north, goes 90 degrees. So this plane is just like here. It flies for 20 miles. And another plane leaves at a bearing of south 35 degrees east. So south 35 degrees east. I'm sorry, I gotta like for 50 miles. So the 35 degrees is here. So that one, they didn't use the airline traffic bearing. They just told you the directions. And the question is, how far are the two planes from each other? Okay, so because we do not know any other information, we have not learned any other chapters yet that will allow us to do anything else. All we know is right triangle trigonometry. We're going to have to do this with right triangle trigonometry. We're going to have to find right triangles to make this work. You cannot assume that that is a right triangle. It might be, but you can't assume that. So I don't know if it is. So what I start to do is I start to make those compass roses and start finding missing angles where I can. So this one's 35. What's the 90 degree or the complementary one that makes 90 next to it? 55? Okay, those of you that I never give you anything exciting in here. Please work ahead and see if you can figure, please work ahead and see if you can figure this out. I gotta move this down because I can't write on it very good when it's up there. Sorry about that. I just dropped the microphone. Okay, so I'm gonna go other places now. I might extend this line down all the way to here, just so that I have a 90-degree angle. And if I make a 90-degree angle there, I know that this angle should be 55 degrees. Because in geometry, you have a corollary to the triangle sum theorem that says if you have a right triangle, the two acute angles have to also equal 90. So I know that one has to be 55 if that one's 35. I might make a compass rose here. I'll move my 20 a little bit. So now we kind of have like a little puzzle. We have to find this red X. So we have an idea of something we could find. I didn't really label things, so you have to be kind of like descriptive of what you're talking about. We can use trigonometry. If we have one angle and one side, we can use trigonometry to find another side. If we have one angle and one side of a right triangle. Nobody sees one angle and one side up there, so we could find another side of any piece of it at all. Doesn't matter if you find something we don't need. We got to start somewhere. Chris, what do you think?
Could you take like the largest right triangle?
Okay.
And find like the left side of it using the 35 degree.
Okay, let me highlight what you're talking about. So you're talking about this triangle here, right? And you're saying like the vertical side using the 35 up here. Okay, if we use that 35 up here, and then what side would that be that you're trying to find, like of that triangle, what side would that be?
That would be
The adjacent. Oops, that's not what I wanted to write with. And then what side do we know? Hypotenuse, okay. So if we do adjacent to hypotenuse, that's cosine. Cosine of 35, right? 55. 35 is equal to the adjacent over 50. So this side here has got to be 50 cosine 35 degrees. Okay, I got a side. I do think that is helpful. Don't know if you guys can find out why. Chris?
because it's like the one side on the triangle of X.
Okay, so I can read your mind, so I'm going to highlight what you're talking about. He says the one side of the triangle of X, talking about that vertical side, is going to be exactly the same as the A that we just found, this vertical side right here. So that is also going to be 50 cosine 35. That's what you're talking about, right? Okay. Should have zoomed in so I could write it better. Okay. Other ideas? Lydia, I feel like you had an idea. Yeah. What are you talking about? Oh, can we find the bottom side of the yellow highlighted triangle? Sure. How do you want to do that? I could say two ways, so. How can we find this bottom side? Anybody? How can we find this bottom side of the yellow highlighted triangle? I feel like a girl talked. What? A Pythagorean theorem. You could use Pythagorean theorem. You can also use trigonometry. The way that we found this side, we could use sine instead of cosine to find this side. Either of those is fine. I'm going to use trig only because it's less writing for me. So I'm going to say that this side would be sine 50 sine 35, where this side was 50 cosine 35. But you could also use the Pythagorean theorem to find it. That's fine too. But that's the whole side. That's the whole side. That's important that I say that. Caitlin.
Can't we find like the bottom angle that's like across from like the 55.
You're going to have to give me a color or something like that.
It's like the one where like the yellow and the purple kind of like overlap.
This one here?
Yeah.
How?
If we make that like theta, would we do adjacent over opposite?
So what right triangle is that part of? That's the problem, is I don't know the angles of that, so I don't know that it's necessarily in a right triangle.
Well, they couldn't.
And I'll tell you, I don't even think we I don't think we actually need that angle. I mean, that's definitely a good thing to look at, but oops. But unfortunately, I don't have enough information about those angles to try to figure it out. So I'm going to stick with looking at side lengths. Chris, you're patiently holding that hand.
Can't you subtract 20 from 50 sine 35 to find the measurement of like the base angle
Of the pink one? Yeah. So yeah, you guys remember the 20 up here on the top? Well, that's also going to be 20 down here. I kind of made a rectangle right here. So this little piece right here is going to be 50 sine 35 degrees minus 20. That's going to be that piece down there. Yes?
And then, can't you find the vertical side of that triangle, but it can do 55?
Hold on, the vertical side of which triangle?
The one we just found, that side.
The pink one?
Yeah.
Well, didn't we already find the vertical side? So we have the vertical and we have the base and the what's it called? Height. We have the base and the height of that right triangle. So what can we do? We can do Pythagorean theorem. Yeah, we can do Pythagorean theorem. So 50 cosine 35, your calculator is going to open up an extra parenthesis, so I'll draw that squared, plus, and then we're going to have to do 50 sine, it's going to open up a parenthesis 35, close that parenthesis, minus 20, close that parenthesis, squared, and then you have to square root that. You guys did a really good job of problem solving just now. And that is a skill that is priceless when it comes to you being successful, being a problem solver. Did you get 41.867-ish? Okay. So the way that we're going to finish up our trigonometric unit upon units is with real life application. That's the only thing that's left. This will not be on our test. Our test is not real life application at all. So what's coming up for the rest of this semester, I should say, And then the very beginning of January is just going to be a real life application where the tough part is going to be setting it up and figuring out how to solve it, figuring out what formula to use where. This is just, we've only gone over bearings and angle of elevation and depression. There's a couple more things coming. But that's really all it is going to be for the rest of trig. And then we'll be done with trig. Okay.